So we're back here to talk a little bit more about conditional statements and some reasoning that you can do based on conditional statements, and we call it deductive reasoning. So first of all, what is deductive reasoning? It's a type of reasoning, so a thought process that you use facts, you use definitions, properties, and some laws of logic, which we'll talk about, to make conclusions. So we did this when we talked about proof. We were reasoning by using facts, um, properties, say, of triangles, definitions we had, like midpoint, and we were able to draw conclusions, and it was all based on fact. So the first law that we can use to reason like this is the law of detachment. Okay, so we are going to be given a conditional statement, and then if we have an example of the hypothesis of that conditional statement that is a true thing, then we can draw this conclusion. So it's best to use an example to show how we can use the law of detachment. So here we have some things given. We have this conditional. If two segments have the same length, then they are congruent. So let's do what we did in the last lesson, and we will find our hypothesis. Two segments have the same length. And our conclusion, they are congruent. So we have a if-then statement, a conditional. The law of detachment says if we get a true example of the hypothesis. So if we have an example of two segments that have the same length, then we can make a conclusion. So here we're also given this statement, segment BC, or the length of segment BC, is equal to the length of segment XY. So we have two segments that have the same length. Now, based on this conditional statement and this one example, we can draw a conclusion. And our conclusion would be that segment BC is congruent to segment XY. So this is what we can conclude, because in our conditional statement, the conclusion was they are congruent. So we have our equal length segments, BC and XY. We can draw the conclusion that they are congruent. So let's do a couple more examples of that. I think I have one example that will work and one example that will not work, because you can't always draw a conclusion. So I always like to start out finding hypothesis and conclusion. Our hypothesis is it is Friday night. Our conclusion is Mary goes to the movies. And we're also told that it is Friday night. So it is Friday night is an example of our hypothesis. So we can now make a conclusion. Our conclusion would be, since it's Friday night, Mary goes to the movies. So because we had an example of the hypothesis, we know that we can make a conclusion based off of the conclusion Mary goes to the movies. In this second example, I will find the hypothesis. A book is a biography. And my conclusion, it is fiction. So now let's look at this statement here. You are reading a fiction book. So reading a fiction book is an example of our conclusion. A book is fiction. So since we're not given an example of the hypothesis, we don't know anything about this book being a biography, we can't make any conclusions. So in this example, we cannot draw a conclusion. So it's important, if you want to use the law of detachment, that your example is an example of the hypothesis. Our second law, we're going to talk about two laws, so this is the second of the two. We're given two conditional statements this time. It's called the Law of Syllogism. So our two conditional statements, the first one, we have our hypothesis is P and our conclusion is Q. And since we have a third piece, we need to use some different letters. So in our second statement, our hypothesis is going to be the same Q. And the new conclusion is we like to call R. So if we have this set up where we have if P then Q, and I'll write that out, if P then Q, and then we have if Q then R, we can make this conclusion down here if P then R. So we can write a new conditional where we just use P and R. So again, it's best to look at an example here. We're going to start the way that we've started with detachment. I want to look at each statement and find the hypothesis, find the conclusion. So here, Rick takes chemistry this year. That's our P. Our Q is Jesse will be Rick's lab partner. So now what we have to do is look at the hypothesis of the next conditional statement and see if it's same as Q. Jesse is Rick's lab partner. It's not worded exactly the same, but it is the same idea. So this is Q again. And our conclusion of this statement, Rick will get an A in chemistry. That's what we're going to call R. So we do have if P then Q and if Q then R. So the thing that we can conclude is if P then R, which would be if Rick takes chemistry this year, then, and our conclusion of this statement will be what R was, Rick will get an A in chemistry. So we can skip over the whole part about Jesse because we know if Rick takes chemistry, Jesse will be his lab partner. We're told Jesse's his lab partner, he'll get an A. So we know if Rick takes chemistry this year, then Rick will get an A in chemistry. So let's look at a couple examples. You can't always draw a conclusion, and that will be if you don't have the appropriate setup. So we've got to look at these carefully. Start with the first statement. If you get an A or better on your math test, that's our P. You can go to the movies is our Q. So P and Q from the first one. Now we need the beginning of the next statement to be the same as Q. You go to the movies. Not exactly word the same, but same idea. There's Q again. And the end of this, you can watch your favorite actor. That will be our R, because it's a different state. So we do have if P, then Q, if Q, then R. So we can write a new statement. If you get an A or better on your math test, and we'll use R at the end, then you can watch your favorite actor. So given those two statements, we can draw the conclusion. Getting an A on your math test will allow you to watch your favorite actor. So let's look at an example where we can't draw a conclusion. We'll look at our first statement. A polygon is regular. That's our P. Our Q is all angles in the interior of the polygon are congruent. I know that's a little bit long. So now, in order to use syllogism, the beginning of our next statement needs to be the same as Q, and the beginning of our next statement is not the same as Q. In fact, it's the same as P. A polygon is regular. We do have a new statement R. All of its sides are congruent. But in order to use syllogism, the end of, or the conclusion of the first statement must be the same as the hypothesis of the next statement. That's not the case, so we cannot draw a conclusion. So go ahead and use those notes, like I like to call them. Use your swimmies, help you answer these two you-try questions. Remember, detachment has one conditional statement. Syllogism uses two conditional statements.